Thank you, Nirupam. And first of all, let me thank the organizers for giving me this opportunity. And also, I apologize for not being there in person. I would have loved to be there. I'll be talking about Asian population in obscured environment using radio continuum surveys. And this work is being done with Abhijit, Kyle, Ishwar, and Yogesh. So I'll begin with showing you the GMRT image. And then one can see that there are a variety of sources. One can identify radio galaxies, remnant radio galaxies, diffuse extended emission, and point sources. So the take-home message is from here itself is that we detect a diverse population of AGN. And here I show you a plot which is radio luminosity versus radio size, because we know that many of these galaxies they go beyond the host galaxies, and then their extent is something like a few megaparsec. These are the extreme kind of sources. But these sources begin their journey at much a smaller scale when they're launched, and then we also see jets which are just a parsec scale. And based on their properties, they have been classified in different classes. And what you can see here that there are two populations. Why is that these Seaford galaxies are liners, which are radio quiet sources, and we don't see large scale jets in these sources, and there are radio quiet quasars. But what we, right now, I will be focusing on in this population, and in fact, this is what we are getting, that we can classify as a compact symmetric object. You got PD spectrum sources, compact STP spectrum sources, FR1, FR2 radio galaxies, and remnant radio galaxies, and it is believed that these compact sources evolved into FR1, FR2 type radio galaxies. And in fact, it may not be that all compact sources eventually evolves. In fact, many of them get frustrated and never evolves as a big radio galaxies. But here, what I'll be addressing is a different question: that are there hidden or obscured AGN that we can detect them in one wavelength, but we do not detect them at other wavelength. And the potential sites are dust obscured galaxies, and these galaxies are very faint in optical but bright in infrared and sub-millimeter galaxies. And in order to address these questions, we also require multi-wavelength surveys, and we need to cross-match radio sources with optical, IR, and X-ray. And here I show you spectral energy distribution of rust obscured galaxies. And as I said, that these are very bright, and one can see that they peak in far infrared or mid infrared, depending on how much is the contribution from AGN, how much is the contribution from star formation. And there could also be cases where these could be just like a starburst galaxies, and then we see a cool dust, and then mostly a far infrared or sub-millimeter. But there are also cases where we have a strong AGN. And in literature, these are being classified as a taking the flux ratio of 24 micron to R band optical more than 1000. And here I show you the images, and one can easily see that we barely see anything in optical or even near infrared. The moment you go to near IR or mid IR, these sources begins to brighten up. So it is believed that these are particularly dust obscured galaxies. These are merger driven sources where you can see that a lot of material eventually inflows onto the supermassive black hole, and then the accretion rate goes up, and also that there's a lot of obscuration around the AGN. And these could eventually, in fact, these leads to an obscured AGN. And it may happen that later on these become unobscured because the radiation drives out the material, whatever is there. And these are most likely to be early evolutionary phase, and these are kind of luminous infrared galaxies or ultra luminous infrared galaxies, and mostly found at a higher redshift of something like more than 1. So here, what we did is we used VGMRT band 3 observations, and this is, I'm showing you one deep pointing with 10 hours of observations, and with that we could reach to a 30 microjansky median RMS. And the large number of sources are there. We picked up only those sources which eventually satisfies the criteria of being dust obscured galaxies. And here I show you the footprints of multi-wavelength surveys, and which is required and also essential. So we have a UGMRT observation. We also have this field is covered by VLA, LOFAR, and also the MeerKAT. This is XMM LSS field, and there are also optical IR and X-ray surveys. So here I have listed them. So we could begin with a sample of 321 dust obscured galaxies using this criteria, which are falling in the UGMRT region. And this is the one case I'm showing you that these are right in 24 micron, but barely you could see, even with the Subaru R-band hyper supreme cam image, we barely could see. These are typical R-band magnitude is around 24, 25, or 26 also, and some of them are in fact much fainter. And with the UGMRT, we could get a very bright emission. And here, this is the VLA image, and you can see that the UGMRT image is very bright, and this could be the possibility because this is a steep spectrum source. So you get a lot of flux in the UGMRT band. So here I show you the detection rate. One can easily notice that if you look at the first or VLASS, these are large area shallow surveys. So VLA, even 1% dust obscured galaxies are detected with first or VLASS. But the moment we use a deep field radio continuum observations, these shoot up to something like 25 to 30%. And once we combine UGMRT and VLA, at least even if a source is detected in one of them, either in UGMRT or in GAVLA, we could detect 34% of these sources. And then we further analyze that what is their properties, and what we are finding that these are radio loud AGN mostly, because their luminosity is more than 10 to the power 24 watt per hertz. And if these are powered by star formation, then star formation has to be enormously high, which is something like 300 solar mass per year. But when we look at the radio SEDs or even the this radio color plot, these are unlikely to be powered by star formation because we see steep or flat spectrum. And these sources are also unresolved mostly. In few cases we could resolve, and their typical size is something like a few kiloparsec or 10 to 20 kiloparsec. But most of the sources are we could barely set the upper limit on these courses. So here is a radio kind of speckle index, which is just a 2-point speckle index, and then we are plotting radio size versus speckle index. And what we are finding that many of these sources are compact steep spectrum sources, because they are compact and their speckle index is very, very steep. And in some cases, we get flat speckle index, and we guess that these could be gigahertz peak spectrum like sources, but we need to do a detailed analysis, which we are doing at the moment. So there is a hint that these could be likely to be a young radio sources which are hosted in obscured galaxies. And there were large number of sources which remained undetected in UGMRT and JVLA surveys. And then what we did that we utilized the stacking method. So we stacked all these radio image cutouts which are centered at the optical position of dust obscured galaxies, and we could detect clear detection. So here in this case, you can see that by stacking 116 images, we could reach to a RMS of something like 3.5 microjansky with the UGMRT images, and similarly with the JVLA. So it means that there is a radio emission which is still yet to be detected in these galaxies. And with the median taking a median redshift, we believe that this could be a kind of low luminosity AGNs. So these are still hidden and not will explode, and are likely to be detected with a deeper observation with a SK kind of surveys. We also see a population where we detect them in radio, but there is no optical or IR counterpart. And these are again likely to be a potentially obscured high-G sources. So what you can see that these are kind of some Iliev radio sources, and they are not even detected in split surveys. So another requirement, in addition to the deep radio continuum surveys, we also require a deep optical and IR surveys. Here we looked at the X-ray properties of these sources, and X-ray detection rate is very low, something like 78% with the Chandra and XMM Newton. And often we encounter the problem of poor quality X-ray spectra, and which is quite expected if obscure sources are at high redshift and heavily obscured, then X-ray photons are mostly absorbed. And this is the one case we are showing a source at redshift of 3.2. And we in some cases we could get reasonably good spectra, and we could fit and derive the column density. And here the column density versus Eddington ratio plot. Eddington ratio basically infers the accretion rate. And what we see that the most of these sources are, of course, obscured with a column density of 10 to the power 22 or more. But they are also, in some of the cases, we find a kind of a superinducing sources. And if you look at the X-ray luminosity, these are like a extremely luminous quasar kind of sources.
Veeresh, you have about 2 more minutes.
Okay, fine. So we are also using this L-band VCAT, which is MIT survey and the super MIT survey, and these are led by Dharam and Russ Taylor. And what we see that, of course, detection rates is very high with the MIT as well as super MIT. But now the question will be that whether these are star-forming galaxies or high-density regions. So here is my summary. So with the deep UGMRT and also VLA observation, we detect hidden AGN population in dust obscured galaxies, and detection rate is much higher if you compare with the previous shallow observations or X-ray observations. And once you look at the radio properties, these are likely to be ion radio sources, where jet is still embedded within the dusty environment. And we believe that given the higher sensitivity, MIT, SuperMIT, and SKO surveys will reveal more. Thank you.
Yes, show questions.
Veeresh, so are these sources similar to the gas-rich ULERGs or the submillimeter galaxies?
Yes, many of them. So yes, I mean we looked at the IR luminosity and they are quite similar.
Okay, thank you.
Okay, anything else? Any other question? Veeresh, at the beginning, the slide, general question, the slide that you showed that things which are not detectable currently with the sensitivity, is that sort of assuming an isotropic luminosity or what?
Are you
one of the very early plot where you showed this different thing in the size versus their luminosity, I guess, and then the,
okay,
the line drawn is that with some assumption of isotropy and
this is mostly for this remnant radio galaxies where these galaxies now they don't have no more active AGN or jets are not sustained at all. So you have just remnant loops, and these are they're fading away due to radiative cooling and or maybe adiabatic expansion. So because we don't detect them, I mean that is what the main thing, that we haven't detected extremely large sources. I mean we're talking about something like 10 to the power 5 parsec. This is the log scale, and these are likely to be extended diffuse emissions, so they haven't been detected.
Okay, yeah. So if there is no other question, let's thank Veeresh and we move to the next talk.